Hello everyone. I am Achyutananda, lecturer in Department of Civil Engineering from Ganesh Institute of Engineering and Technology. So today we are going to discuss about gauge, which is the part of railway and bridge engineering. Railway and bridge engineering. So gauge is the main substance. Gauge is the main substance of a railway. So if we tell about gauge is the clear minimum horizontal distance between the inner faces of two rails forming a track is known as gauge. Means if we see so today's generation we usually use bull-headed rails. If this is one part of rails, one cross section of one part of rails, and this is the another part of rails. This is two rails which we construct in the railway, and this is the part of slipper by which the rail is tied up, and this is one rail and this is another rail. So the clear minimum horizontal distance of inner face of railway, like if we see the train is moving this side of the rails, and this is the outer face of the rails, and this one is the inner face of rail. If we see this portion, this distance is known as gauge. This clear horizontal distance is known as gauge. So there are various types of gauge which Indian Railway use for rail tracks. So there are majorly basically we use three types of gauge. There are the types of gauge there are three types of gauge. First one is broad gauge, which we know shortly the BG, and second one is meter gauge. This is MG, and third one is narrow gauge. Which is NG. So there are three basic types of gauge which Indian Railway considered in the rail tracks. There are some standard widths of these three rails, these three gauge. First, if we see of BG means broad gauge, this is the width is 1.676 meter, and if with the meter gauge, the distance is 1.00 meter, means 1 meter, and for the narrow gauge the distance is 0.762. That means 762 millimeter. This is 0.762 meter. Now let's see what is broad gauge. Broad gauge, when the clear horizontal distance between the inner face of two parallel rails forming a track is 1676 the gauge is called broad gauge. In the sense, if we see this is the rail track, the cross section area of one rail. This looks like one rail. As we know, there are two rails there are two rails we put in the railway. This is another rail. For BG, means for a broad gauge, the distance should be, if the distance is 1.676 meter, 1676 millimeter, then we tell this is as broad gauge. The gauge is also known as standard gauge of India. Means this broad gauge is vast. If we see, there are three types of gauge. The major use of gauge is broad gauge. The broad gauge is one type of gauge which we majorly use in Indian Railway. So the broad gauge is also 50% of Indian Railway tracks have been laid into this gauge. If we see if we measure the rail track in India is 100%, then 50% of Indian rail is laying in broad gauge distance, means 1.76 meter distance. Okay, there are some suitability also. The suitability of broad gauge is when sufficient funds are available for Indian railway project. If the government gives the sufficient fund for the railway construction, then the gauge is known as this is the suitable for broad gauge. And the second suitability is when the prospects of revenue are very bright, means the government wants to construct and find railway, there is a bright railway, there is the railway is too much clear, maybe the area is urban area, then the uses of gauge is broad gauge. And if we tell another thing, therefore the broad gauge is used for tracks in plain area, means if the area is in plain surface, the broad gauge is constructed, and densely populated for routes of maximum traffic, incentives, and places which are centers of industry and commerce. In the sense, if there are some major area like cities, like industrial area, and there the population is high, then we use the broad gauge system in the railway track. Then come to the meter gauge. Meter gauge is a type of gauge which the clear horizontal minimum distance is 1000 mm, in the sense 1 meter. So if we see, as the broad gauge is considered as 1.676 meter is equal to 1676 millimeter. As the meter gauge, the distance is 1 meter. As the name is meter, this is considered as 1 meter. If we see this is the inner face of rail. This is two rails. This one is another rail. And this is the inner face of rail in mg. This is the meter gauge. The distance should be 1 meter or 1000 millimeter. So this is known as meter gauge. If we see the distance of two inner face railway is 1 meter, then we can tell that their gauge as meter gauge. So there are also some suitability. First, if we see in Indian railway, as we know, for 50% of Indian railway track constructed as broad gauge, and if we see 40%, if in from 100% meter gauge considered as broad gauge considered 50%, meter gauge is 40%. 40% of Indian railway construct their construction of gauge, consider their gauge as meter gauge. 50% of which broad gauge, 40% is meter gauge. And what is the suitability? Meter gauge is suitable like when the funds available for the railway project are incredible. In the sense, the fund is not minimum, not maximum. This is a between price. This in that criteria we use meter gauge for construction of railway. Then the next suitability is when the prospects of revenue are not very bright, means there are some obstructions, there are some rough areas, there are some politics. In that situation, we use the meter gauge. Also, the use of track is underdeveloped area in interior areas where traffic intensely small and prospects of future development are not very bright. In the sense, if we see some going to develop area like village, and there are some village the traffic is too small, like we know in villages there are no traffic are there. There are small stations, there are small PH roads, we can say. In that criteria we use meter gauge for the railway. And another gauge is narrow gauge. If we see narrow gauge NG, as we know, the distance of narrow gauge is 0.762, when the clear horizontal minimum distance, which you know as gauge, is 0.762 meter or 762 millimeter, then this gauge is known as narrow gauge. If we see, if this is the gauge part, this is the rail, first rail, and this is the second rail, and the inner face distance is 0.762 meter or 762 millimeter. Then this is known as narrow gauge. Okay, so what is narrow? If we know if the distance is 762 mm or 0.762 meter, then we can say that this is as a narrow gauge. And the suitability are when the construction of track with wider gauge is provided due to the provisional sharp curves, steep gradients, narrow bridge and tunnel, etc. This is uses of narrow gauge. If we see, there are some pre-tunnels. There are some pre-casted tunnels. Then there are no space for meter gauge. There are no space for narrow gauge. Sorry, there are no space for broad gauge. There are no space for meter gauge. Then we construct the narrow gauge. And next thing is the prospects of revenue are not very bright. In the sense, the government perspective is not that much clear, that not that much bright to have a look of the railway. Then we construct the narrow gauge in that side. Okay. So therefore where the narrow gauge is constructed in hilly areas, not very thin populated areas like in hilly areas, in slum areas there are like small kind of population. There we used of narrow gauge. And the second perspective is there are like the perspective of government has no more that there are no stations, there are no traffic, there are zero kind of stations, zero kind of traffic. There we constructed the narrow gauge. Okay, so the next part is choice of gauge. How to choose a gauge, how to consider a gauge. There are two types of choices we consider. Before choice of a gauge, we consider two types of criteria. This is the choice of gauge, which is first criteria is cost consideration. And the second thing is, first is cost consideration and the second thing is traffic consideration. In this criteria, in these two facing these two criteria, cost consideration and traffic consideration, we used to choose this gauge in various construction sites, in various railways. So first, if we know what is choice of gauge, the choice of gauge is very limited as each country has a fixed gauge and all new railway lines are constructed to standard gauge. However, the following factors therefore influence for choice of gauge. As we know, there are some standard size, there are some standard size of gauge, there are some standard length of gauge. There are some so small types of choice of gauge. Like if we consider two choices of gauge, first one is cost consideration and second one is traffic consideration. If we see about the cost consideration, there are, as we know, the government of Indian Railway, the government for narrow gauge, there are no bright fund for this railway track because it is constructed in hilly areas. This is constructed in the no traffic area, village area, there are slum areas also. So if we see about the cost consideration, there is only marginal increase of this cost of the track if a wider gauge is adopted. In this connection, the following points are important. Which points we have to see? First one is there is a proportional increase in the cost equation is of land, earthwork, rails, slipper, ballast, and other track items when constructed wider gauge. In the sense, if we see, if a construction is going to held in one hilly area, there are no facilities. There are no any suitable site to construct precast of railways, precast of slippers. We didn't find any kind of good ballast. In that area, we see the cost consideration. And the second thing is the cost of building bridge, culvert and tunnels increases only marginally due to a wider gauge. If we see, If we if we, there is a necessity of a railway track in there, if we see there is a necessity of the railway track in upon over a river, there we should have to construct one railway bridge for to cross the river. As we see, if we construct one wider bridge, if we see, if we construct one wider bridge or wider culvert to cross the road, then the cost is may increase, the cost may be increasing too high. Maybe the fund is gonna decrease, the fund is not the fund is maybe insufficient for the construction. In that criteria we see the cost consideration. And third thing is the cost of construction, station buildings, platforms, staff quarters, level crossings, signals, etc. associated with the railway network is more or less than same of the all gauges. If we construct on broad gauge, there are no suitability of any construction of stations, there are no suitability of staff rooms, there are no suitability of station buildings and all. So you have to see the cost consideration. Then the fourth thing is the cost of rolling stock is independent of the gauge of the track of carrying of same volume of traffic. We have to also see the bearing capacity of railway. We have to see the load bearing capacity of railway as much as load the if we see there are some goods train which used to transfer some goods like some coals, minerals, we transform from transport from this to this side. So we have to see the cost consideration. Then if it's the traffic consideration is like the volume of traffic depends upon the size of wagons in speed of the hauling capacity of the train. If we see there are some populated area, there are some apartments, there are some houses in near to the behind just side in the railway tracks, then this is one traffic barrier maybe because the working load, the load which increase, the load which put in the railways at the time of railways running, there are some UDL, there are some live loads which is maybe in tons. So we have to see the traffic, if the site is suitable for the railways or not, how the buildings are constructed. If we launch the railway, there are no harm of any populations. We have to see the criteria also. And the second thing is the type of transaction of signaling equipment required for independent of the gauge. Like we know, as we know, if one railway is crossed, there are three types of signals we use in traffic. First one is red and orange, and one is green. There are every color defined every aspects. Like red is there. If we see in traffic in the main normally road traffic, the red sign designate that the please stop. The road is now full. The another place where road is going to cross your road, then you have to stop. And orange is be ready for move, green is move. But in railways we see if there are red signals means the track is engaged, there are maybe there the train is in the track, maybe the train is nearer, then you have no to go. Orange is please the train, orange sign designate that please start your engine to move. And green is the track is free from, if the track is not engaged, the track is free from trains, you can go now. So this is the whole traffic consideration for choice of an gauge. Then if we see the uniformity of gauge, the existence of a uniform gauge country enables smooth, speedy and efficient operation of trains. Like if we see the part slipper which used to constant, which used to put a constant, would put a longitudinal distance, lateral distance to both gauge to stop in stiffness. We use slippers, and this is the uniformity of gauge. If we maintain uniformity, the train runs smoothly, the train runs speedily, and therefore the a single gauge should be adopted irrespective of the minor advantages of wider gauge and the few limitations of narrow gauge. In the sense, if we see the broad gauge is the basic gauge, which 50% of Indian Railway are going to use this gauge in their railway tracks. So we have to, if we maintain it, uniformity. The train moves smoothly, the train moves efficiently, also the train moves speedily in the track, and the time management also maintained in the time. So this is all about gauge in Indian Railway. Thank you.